All right, so for the first one, an advertising agency in a large city is conducting a survey of adults to investigate whether there is an association between the highest level of educational achievement and primary source for news. The company takes a random sample of 2,500 adults in the city. The results are shown in the table below. So this right here is called a what? Two-way table. This is something that is very common as a free response on AP exam, is a two-way table and then asking you probabilities about that two-way table. Looking at part A, tell me a word or wording that is very important in part A to kind of basically tell you what you're getting ready to do. Or. What about with part B? This one's a little bit, it's not as obvious at first. If. So it's an if. Now, this one said if too, but what did that if not include? Much anything, right? It just said if they're selected. So this if actually told us that. What about part C? And then also what? It's definitely checking to see if it's independent. So usually you can kind of narrow this down and decide what it is that you're doing. Or I usually say we associate the word or with what math function. And then sometimes what? Subtracting. And this deals with mutually exclusive, not mutually exclusive stuff. So we have college graduate or, and I'm going to shorthand without giving myself a key here because I don't have much room. Or is or this one, the U1 or the N1? Or internet. So I need to know if those two are what? Are they?
No.
Which means I'm going to have to what?
How do we know they're not mutually exclusive?
Can I be both at the same time? And because they're not mutually exclusive, that means, so like, let's start here. You just told me it's going to be add. So probability of college graduate plus probability of internet. But because they're not mutually exclusive, I'm going to have to what?
Minus probability of college graduate plus internet.
So how do I find, what is the probability of, I have to erase some of this just to do it right better. What is the probability that they're a college graduate? And I don't need to reduce anything. What's the probability that it's college graduate?
600 times 2,500.
Because that's here at a total. What's the probability that they found it from internet?
687 divided by 2,500.
And then where do I find the and? Where they do what? And AP exam does not care how you write this answer as far as it's like in fraction or decimal. But to some extent, you should either get not reduced. I don't really have much room to write this. Not reduced, you would get 1135 over 2,500, and then reduce it, or you get 0.454 as your answer. So the important part about B is the if part, which means this is a what kind of probability? A given. Anything with a condition. So what is given in this problem? So when I write this, I write given college graduate. What is the part now that I'm finding? Probably that what? So when I'm doing this gets super easy in a two-way table because where do I put the given part of it? In the bottom. So what is my total number of college graduates? And how many of those have what I'm looking for?
245.
And then again, you can reduce and write as a decimal 0.354 if you'd rather do it that way. Yeah. Now, C, we are trying to figure out if they are independent. I need more room. How do I figure out if two things are independent? Just give me stuff. Tell me what to do from there.
Equals probability of A given something else.
Right? This is very common for an AP exam, and they'll ask you to do one of these, but they've already asked you problems to do. They've probably already asked you to do this one, so use it. So which one? They already asked us to do internet given college graduate. So what do I want to compare it to?
The probability.
And we just found this answer in B, just it would have given us 0.354. How do I find probability of internet? It's what out of what?
687 or 2.
Does anybody have in front of them what that decimal is?
0.2748.
And those are not equal, so and that is all you would need as your entire justification. Questions on that problem? Both of these problems are very, very typical AP exam questions. Now part D is not what you usually see associated with it, but this is a good problem, especially based off of what y'all were saying the other day. The company wants to conduct a statistical test to investigate whether there is an association between educational achievement and primary source for news for adults in the city. We are given a what? Two-way table. If I am trying to run a test using a two-way table, I am probably doing a what kind of test in general? Chi-squared. My decision is it independent homogeneity? It wouldn't be goodness of fit because goodness of fit wouldn't be a two-way table. So my only decision is homogeneity or independence, which is all based on how you get your information, which is what we talked about today. So up here, what does it say about how we obtain our two-way table?
Survey.
We took a survey of what? Of one population. And we wrote that today. That means it is what? Which one did random selection from one population? So this is and that's all based on how we got the data. What would it look like if it were chi-square test of homogeneity? We would have had to do what instead? Two or more. So like I took a random sample of 370 non-high school graduates. Then separately, I took a random sample of 1,437 this, and then so forth. So it would take separate random samples of each of the populations. And in this, we've also talked about today, it's a two-way table, so how do I find degrees of freedom without numbers? times
Number of columns minus one.
how many rows were there? How many are, we'll go, rows are this way. Well, rows actually go this way, so number of them are this way. How many of this are there? How many columns? So our degrees of freedom is 8. Questions with any part of that problem or anything that problem makes you think of? At number 3, a shopping mall has 3 automated teller machines. Because the machines receive heavy use, they sometimes stop working and need to be repaired. Let the random variable x represent the number of ATMs that are working when the mall opens on a randomly selected day. The table shows the probability of each of the different ones. So we know we're dealing with probability. What's important with part A that kind of stands out? At least. So what am I doing there? Which numbers are at least 1? So what do I do about 1, 2, and 3? Which gives me what? That should be a very easy question. What's keywords with B? How do you find expected value if you have a probability distribution? So I would take 0 times plus 1 times 0.21 plus 2 times 0.4 plus 3 times 0.24, and you end up getting what? 1.73, and what would my units be? And ATMs would be fine. Working is the success. If it's not wrong to put it, but you don't have to put it and still get it right.
Would we need to have the units because it says what the expected value of the number is?
I don't think they would count off for it there, because of what you said. You're right. I always like to include units, because there are times where they do count off for it. But like in a question like this, you're right. They wouldn't count off for it. And like I've said before, sometimes I'm pickier with those little things, so it's a habit that on the AP exams they don't really look for. C, what is the probability that all 3 ATMs are working when the mall opens, given that at least one of the ATMs is working? What's the most important, what's the part there that kind of triggers you what type of problem it is? So, this is essentially what we did for the last problem. So what goes on bottom is this. Well, I already know what's the probability there's at least one working.
Functional. No, wait, sorry. 0.8.
And now, what's the probability that it's also all 3 of them working? And then you're just dividing that out. And you get 0.282 about. To be completely honest, I don't love D because it's an easy question. I like the question itself, but it would be hard for me to answer that, like, as a student taking this test, because, like, I get it, but I don't know how to explain that to you. So given that at least one of the ATMs is working when the mall opens, would the expected value of the number of ATMs working be less than, greater than, or equal to the expected value from part B? Well, what is just the answer? Greater than. That part you should get. because very point blank, I'm just eliminating what? Zero. So if you eliminate zero and it had some pool, I'm now going higher than that. That should make sense. But how to put that into words to explain it is the part that I think is hard as far as testing it for an AP exam. I am going to read you their answer for this. Given that at least one ATM is working when the mall opens, the expected value of the number of working ATMs would be greater than the expected value calculated in Part B. By eliminating the possibility of 0 working ATMs, the probabilities 1, 2, and 3 working ATMs all increase proportionally, so the expected value must increase. I think a lot of people would understand that problem and just, it's hard for me to say that they could put a value on if your words were justified as enough reasoning, I think is my issue there. But you should get the concept that if you take 0 out of it, everything else has more pull and it's going to pull it up from there, and you should be able to get the greater part. Questions on any of these problems from either of these?